Good morning, everyone. So today's lesson will be focused on how to graph something called a simple inequality. That's when you just have something that looks like x less than or greater than or less than or equal to a number. Like in this example, x greater than -7, sorry. And we're going to go ahead and graph this, and this ends up being graphed on a number line because it's a collection of numbers that are bigger than -7. So it's going to look something like this. So we highlight the parts on the number line that are bigger than -7, in this case -6, -5, -4, and so on all the way up to the positive numbers. All right, so what is a good definition for an inequality? So again, remember, an inequality is just a statement that two expressions are not equal to each other, that one is bigger than the other one, or greater than or equal to the other one. So on your paper, you have this definition in the green box. So inequalities work just like equations, but they tell you whether or not the expression is bigger or smaller. Those are the words you're filling in, than the expression on the other side. So on one side, you have something that is either bigger or smaller, depending on the inequality. So again, an inequality is like an equation, but instead of an equal sign, you have one of those four signs: the less than, the greater than, the less than or equal to, and the greater than or equal to. If you're still having trouble remembering these, you may want to write these down somewhere. All right, so let's go ahead and look at this first piece right here. Now, this piece, you don't have it on your notes. I just kind of want to go over it. It's kind of important to know what is the difference between these three expressions. So what is the difference between all three of these? So first one, let's look at the first one, and it says x equal to 2. So that means in here, how many solutions are equal to 2? So in this case, we only have one solution, because the only number that I can replace for the x here is the number 2. So I can say 2 is equal to 2, and that's true. Now there is nothing else that you can put on this spot for the x that would make it true. So in this case, we have one solution. Now for the second one, same thing. What are we allowed to put here? So I can still put the 2. 2 is greater than or equal to 2. That's true because it's focusing on the equals part. So there is one solution here, but there is more than one solution here, because I can also put 3 is greater than 2. I can put 4 is greater than 2. I can put 2.7 is greater than 2, and so on. So there's many solutions here. So here we have an infinite number of solutions, right? Because there's many, many numbers that are greater than or equal to 2. Now for the very last one, we have x greater than 2. So we put this right here would be false. So in this case, this one does not work. So that is incorrect. So 2 is not bigger than itself, although the other numbers work: 3 greater than 2, 4 greater than 2, and so on. So the difference between these two right here is the following: that the one on the left has one extra solution than the one on the right, which is being this one right here. So they're almost the same. There's just one extra answer. So they both have infinite solutions, but the one on the left has that one extra answer that does make it true on the statement, but they still both have infinite solutions. So let's go ahead and go over how to graph these, which is what our focus for today is. So again, graphing when we have a less than, greater than sign. So this is just like when we graph a two-variable expression where we have an open, a line that is solid or broken, but on the number line, we don't have solid and broken lines. We have a solid and open circle. So in this case, we use an open circle to show the number is not a solution. So when we have an open circle, it's hollow. It's not including that number. So for example, if we graph x less than 3, which is on your paper. So again, this is x less than 3. Again, if you're still having trouble with what symbol it is, you should write this down. X is less than 3. We have our number line. So at the number 3, that's where we start. We're going to put an open circle to indicate that 3 is not a solution, because 3 is not less than 3. And then we highlight every single number to the left. And that is pretty much how we graph an inequality. It's just open, closed. That's first question. Shade to the left or shade to the right. Let's look at another example. Here we have x is greater than -5. So we want all the numbers that are bigger than -5, but not -5. So we put an open circle at -5. And we shade to the right. So again, -5, we use an open circle because it's not a solution. That's how we indicate something is not part of my answer set. And when we have the less than or equal to and the greater than or equal to, that means the number will be a solution. So that's why we use a solid circle, or can also call it a closed circle. And this tells me that something is a solution. So when we bubble it in and make it solid, that's saying the number is a solution. So we have this one right here, x, and that's a less than or equal to sign. So x is less than or equal to 8. So we go ahead and go to 8 first, and we put a solid circle here. And there it's getting filled in. Because 8 would make the statement true. I am allowed to go ahead and put an 8 here. And that would make it true. 8 is less than or equal to itself. And then since it's a less than sign, we shade to the left. And this last one, same idea, x is greater than or equal to -5. So at -5, we put our solid circle because -5 is bigger or equal to -5. And greater than means shade to the right. So one more time, 2 choices you need to make. Solid or open, close. Solid, close, or open circle. Solution, not a solution. And then shade to the left, shade to the right, based on if it's less than or greater than. Now let's go ahead and do some together. So look at number 1 right here. We want to make a graph for this, but we should notice that this is not in the order the other ones were. So whenever they give you the number first and then the variable, you have to be careful when you graph it because it's backwards. So what you technically would graph is in reverse. So what usually helps is just to turn it all around. So switch the x and the -8, and then switch the inequality. Again, the opening should still be towards the -8. And then you can go ahead and graph it. So you have your little number line. We're just going to go ahead and put the number on it. I'm just going to put it in the middle, -8. To its left, it's -9, and to the right is -7. I'm going to go ahead and put since it's just a less than, it should be an open circle because I don't have an equal sign here. So I have it as a solution. This is a less than sign, so I go to the left. And I'm pretty much done. That's it. Let's go ahead and move on to the next one. All right, same thing here. It's backwards, so I'm going to flip it around. So again, just be very careful, otherwise it's going to end up graphing to the wrong direction. You have x greater than or equal to 12. We have our number line. Again, it doesn't matter where you put the 12. You can put it first, you can put it second. Oops, that's not supposed to happen. All right, you can put it first, second, or third. It doesn't matter where the 12 is at. Just put it in the middle if you want. 11 to the left and 13 to the right. So it has an equal sign on this one, so I'm going to make it a solid. It's including as a solution. And greater than means shade to the right. Let's move on to the next one. So we're going to state the inequality right here for this graph that's already done for me. So I'm just going to put my x. I'm going to put x is greater than -7. So again, we're here at -7. So even though the number is not written for me, I should know that right here we have the number -7. So I'm going to have my x and my -7, and I know that it's shading to the right. So it's going towards the positives, which is greater than. So we're going to put the greater than sign. Again, it's an open circle, so I don't put the equal, so let's erase that. So it's just strictly greater than -7. Try the fourth one on your own and see you got it. So now that you've tried the fourth one, let's see if we got the inequality correctly. So here we have, it's shading to the left, so it's a less than. We're at the number 2, and it's a solid number. So we want all the numbers that are smaller than or equal to 2. So x is less than or equal to 2. So we're going to use a less than or equal to symbol, and that does not have the equal symbol on it, so let's add it in. So we still need the little line right there. All right, and that's pretty much it for that one. Let's go ahead and move on. All right, so for our inequality symbols, sometimes we'll have words that relate to them as well. So here are a few words that also mean less than, greater than, and so on. So for the first one, fewer than would also refer to less than. More than also means greater than. Exceeds, so it goes bigger than, means greater than as well. We have no more than, which means less than or equal to, which means it cannot go past this point, so it's got to be under. At most means no higher than this, so it's at this point or lower. And same thing going backwards. No less than and at least. Let's go ahead and pause this and continue writing this down. All right, let's look at some quick application problems. So Anthony is shopping for a birthday gift for his cousin Robert. He has $25 in his wallet. Write an inequality that shows how many dollars he can spend for the gift. So since he only has $25, he cannot spend more than $25. He can spend all $25 or less. So in this case, we would say A is less than or equal to 25. And I just use the A for Anthony. Next one, Teresa is only allowed to swim outside if the temperature outside is at least 85 degrees. So again, at least is our keyword, 85 degrees, right? And an inequality, so at least meaning it has to be 85 degrees and greater. So we would have T for Teresa is greater than or equal to 85. So the temperature has to be 85 minimum, so it's got to be bigger than 85. Anything lower would be too cold. So in order to achieve an A in math, Ivy needs to score 95% on her next test. We're going to write an inequality that shows where she's going to get this A in math. So again, she's got to score more than 95. So it's going to be a greater than, more than, but she cannot score 95. It has to be higher than 95. So there's no equals here. So I greater than 95. All right, so these are just a few examples of applications of the inequalities. Your task is to work on your iExcel and your practice pages. Good luck.